Yeah, I wanted to follow up here. I made a little USB signal loss video because originally I did not even get my sled built, and I had a signal loss in the USB, and so I started investigating the noise, and I took a lot of steps here. And I'm not going to repeat everything. Just watch that first video. It's on the same channel. This one's on here too. But FYI, this is what I found out here too. Suppress the noise and spikes. I have active filters plus chokes on my system, and both those systems has really helped a lot here too. And I put that on all power cords as well as USB cords then too, and that's really helped right there too. Now, I've also found that my router is the noisiest when it comes electronically, um, and it's actually getting worse. Originally, when I first did the first video, the router was fairly new, and I was getting noise ratings of 0.01. And now I have about 30 hours of runtime on this router. And I have to say, I have about 30 hours of runtime with no error losses and actually no errors at all since I've implemented all these changes here too. But I've also noted my rigid router is actually getting noisier. In fact, it used to be 0.01. Now it's like bouncing 0.02 all the time. So I'm getting some noise here too. I'm not sure why, but if I have to venture a guess, it's probably because of the dust and the brushes or something. It's just causing some noise there too. So another recommendation here is separating all the wires. Now, I'm not talking about separating the wires from the bundles, from the power, from the encoders, but just making sure that all the different strands of wire or all different bundles of wire are separated as much as possible from them too. Um, in fact, I'm going to jump ahead right here too a little bit because, the pulse width modulation, that is the constant um, building of power and then decreasing. It's actually these pulses that go through, and each one of them actually has a magnetic flux built around when the pulse is on, and it collapses when the pulse is off. In fact, if you've ever seen Faraday's experiment of passing a magnet over a wire, well, that's how you induce current into a wire, any wire, including the encoder wires. So someone needs to probably, for a future design, or if you're really having trouble with signal loss or accuracy even, I think twisted pair or shielding these wires. That might be a nice easy retrofit to do, because then we can actually have it these wires are separated. And any good design when it comes to encoders, I see, is basically separating the encoder wires from the power wires, especially when pulse width modulation here too. So um, I have not separated the individual uh, bundles. I just separated the bundles from each other then too, and so, and in fact, that's what I also did on my router. I built these little things here. These are little rings that just fit around my vacuum cord right here, because I kept thinking about this. Well, I've done a lot of steps trying to clean up my AC signal. But of course, the AC signal is going to get processed and turned into DC. There's going to be some filtering in that process as well. So I kept thinking, well, where else could these faulty signals be getting into the Arduino? And I started thinking about my Z-axis. I know the router is very, very noisy, and I had my Z-axis cabling snugged right up to it all the way through, nice and neat. And I thought, well, this can't be. So I went ahead and built this. In fact, here's every single one of them, every 6-8 inches or whatever, and just sort of to keep it separated. Now you can actually have some casual crossing. That's not a big deal. It's basically the longer these things are running right next to each other, the more the magnetic flux is going to induce into it. So that's something to think about here too. And I have to say, I'm really been happy about the accuracy. In fact, I just had this thing, the Maslow, build this great grid system, I should say. It's a vent for a fan, and I even had it make the Maslow cut the grooves in the side here too. Um, I designed it in Fusion 360 and had it cut, and I'm just incredibly impressed at how accurate it is. In fact, I did some things that actually help. Most of my cutting was, of course, in the middle of the board. I just would advance this sheet here. This is 1/4 inch, probably 5 or 6 ply 1/4 inch plywood. And each piece now is not just cut at one time. There's 3 passes. on every piece then too. I didn't have it cut very deeply, and I was really impressed how accurate it was. So anyway, I'm thinking the accuracy that I'm getting may be due because all these things I've done to get rid of the noise and separate it and isolate it. And I know I keep hearing from the forum other people are actually having accuracy problems, and so this may be something to think about here too. But I've been really impressed here too. So, but again, I got 30 hours of runtime, so things are working fine here too. And just as a little teaser, I got on the video coming up here too, but I went ahead and rebuilt my Z axis because that's, of course, is the weak link here too. And I found this nice little lead screw on eBay, built the aluminum angle brace for it here too, and even built the aluminum holders here too. But this top piece here is just a 3D printed piece, which I was able to just print off, design and print off, and I'll post this to Thingiverse here too coming up here too. But here's a prototype, and very, very strong. This is the weaker one because I didn't put a lot of structures. This is just trying to get my measurements right and everything corrected too. But yeah, it was really simple. In fact, it even used the same shaft couplers because this particular lead screw I got is the same diameter. So anyway, I will talk about that in the future here too. But anyway, implement these changes I've done on the USB signal loss for 1 and 2. Implement all these things right here, and I think you'll have a lot better luck. So anyway, happy Maslowing.